Hello, we're still working on the 2008 multiple choice. Okay, I'm having too much fun doing these problems. Okay, so this one is logistic. It's very appropriate now with what we're talking about, is that things grow exponentially and then sometimes they flatten out. Okay, so that is logistic. So this is a logistic curve. Now, it does say logistic growth. Okay, so the question is, how did we do this first semester? So how did we do this a long time ago when we were working on logistic? So if you remember the long way, okay, so let's talk about the long way. So in the long way, we ended up with a dt over here and a number, okay, and then whatever was over there ended up over here. So it was like dp, and then there were p's down here. Okay, there were either two parentheses or one had a p and one had some number minus p, something like that. We needed partial fractions. Okay, so we needed partial fractions. Now, if this is on the IB or on the IB exam, it's not on the IB exam. If it was on the BC exam and the free response, there's a good one from, I don't know, 1994. I'll have to find it for you. I think it's 94. Let's see. No, I was at Bonita High School. 98, 97? I'll have to look for it for you. It was my first year I taught BC over there, and they had this crazy question where lots of people graphed it, lots of people tried to solve it, and it was so difficult, and then they didn't get to the Taylor series at the end. So maybe we should take a look at that one. I'll add that to my list here of the free responses that we want to go over. So we want to go over that logistic free response. Okay. Anyway, okay, so it turned out that they didn't want you to solve it. They wanted you just to graph it. So you should look at those notes that we have. So I'm thinking here, if I factored out a p, that's 0.2 minus 0.001 p. I feel like this one might be a logistic. Look, dp over p, 0.2 minus 0.001 p equals, and then we would put the dt up, so that would be, you could just take that whole thing down, and then there would just be a 1 and a dt right here, and then you integrate both sides. That definitely requires partial fractions. So I'm thinking A looks good. So then does B and C and D and E. Okay, so never mind on that. So let me erase this and let's have a new plan. It could model the one shown in the figure above. Okay, well, what is the slope here at 200? Now, what's 200 there? To me, that looks like P is 200 there. So the slope is 0 if you actually got to 200. Okay, so when I look at these, if I substitute in a 200, I'm supposed to get a slope of 0, and dp dt is the slope. So I'm looking at E because I think this is not the right answer. 0.1 times 200 squared plus 0.001 times 200. That's definitely not 0, so it's not E. Okay, the next group are minuses. Let me factor out the 0.1. Let me factor out the 0.1. So factor out 1.1 p, and then that would be p minus 0.00, or how about 0.01? Moved it over one decimal place. Took out the p already. Okay. I don't believe that one is going to give me, if I put in a 200, that doesn't give me 0. So that one's not looking good. I also think that this slope these slopes do look positive for big values. So this isn't too bad at the moment. Okay, so let's see. So this is 0.2, and then that's P. Oh, we want to take a P out as well. And then that's P minus, so 0.001, and I need to divide 0.2 into that. Move over 1 decimal, move over 1 decimal. That's 0, 0, 0, 5, 0.005. I'm thinking that just doesn't seem right. Oh, that's a 0.2, so that would be here, 0.005. Okay. I'm thinking that's not a good one. Okay, so I kind of like A. Okay, so I like A. What I like about A is it has a 2 in it. Okay, so let's take out a 0.2 P and see what we have here. So this is 1 minus, and then let me divide that again. So let me divide 0.001 divided by 0.2 a different way. Move over 1 place, move over 1 place. Let me move over 2 more places, 2 more places. 1 over 2,000, 200 would be 5 over 1,000, 0.005. Okay, so I guess my division was right. Okay, 0.005 P. Okay, so I believe if I put in a 200 here, oh, we should leave it. Let's leave it my new way. Oh, let's leave it. Let's leave it as 1 over 200. Look at 1 over 200. When you plug in a 200, you get 0. So the slope is 0 there. Very interesting. I don't see another plan. I really don't. This one is 0.1 P, and then that's 1 minus 0.01 P. And then if I substituted 200 in here, it's not the same. If I substituted 100 in there, it would give it to me. Huh. Very odd. Yeah, so A. Not in love with that question. Logistics, though. It's a good thing to look up and study. Okay. And let's see what Mr. Calculus said. Mr. Calculus said only one of the 5 choices can be put in this form. So he forced it into this form as well. Okay. He doesn't show the ones that don't work, but he did find that the same one worked as me. So A. Very interesting. Okay. Okay, let's look at this one. So 24 is definitely a BC topic. I haven't been writing that on all of them, but this is definitely a BC topic. Okay, let's look at 25. I'm not sure if I could fit 25. I think I can. We'll see if we can. Okay, differentiable. Okay, differentiable. Rule 1 says that f of a exists. So you have to get a number. Rule number 2 is the limit has to exist. But for the limit to exist, really the limit from the left has to equal the limit from the right. Okay, this is the limit from the right equals the limit from the left. The left is the negative and the right is the positive. And then rule 3 is rule 1 equals rule 2, which formally on the free response section, you would write this. Now, why did I do these rules? These are not the differentiable rules. So why did I write them? Because I call rule differentiable rule 4. Why do I call it rule 4? Because one of my students told me a long, long time ago, I think my first year teaching AP, he said, Miss Nichols, why don't you call it rule 4? Because you're telling us, don't forget to do rules 1 through 3. Don't forget to do rules 1 through 3. He said, so name it 4. Okay, good idea. So rule 4 is the slope from the left has to equal the slope from the right. Okay, but we do have to make the rules 1 through 3, which are continuity rules, and then rules 1 through 4 are differentiable rules. Okay, so they definitely have to both be true. Okay, so over here, let's take the derivative. Now when I take the derivative, I get c, and then I usually drop the equal to signs. Take the derivative here, 2x minus c, and that's for x is greater than 2. Okay, so let's check. So f of a is a number. Okay, what number is a? So f of 2. Okay, so a is 2 in our example. So if we were showing this in a neat free response way, I would say for step 1, I would say that f of 2 equals, and then I have to find out where that is. Now, I always call that the closed dot. So if I was looking at a graph. But I'm going to substitute this in to the top equation because of this equal to sign right there. So that's c times 2 plus d, 2c plus d. Okay, I did get a number if c and d are numbers. Okay, step 2 says take the limit as x approaches a, which is 2, from the left side, and take the limit as x approaches 2 from the right side. And I need to get the same value. So the left side would be the less than side, and the positive is the greater than side. So the less than side would be cx plus d, and then I'll work out that limit. And the right-hand side is the x squared minus cx. So you substitute that value in, 2c plus d. Substitute this value in. That's 4 minus 2c. And these are supposed to be equal. So 2c plus d equals 4 minus 2c. So let's put a box around that and star it so we can find it. Okay, now step 3 for continuity says that steps 1 has to equal step 2. So if I make these two equal, I'll highlight them. Let's see. So if I make these two equal, then they're going to also be equal to this one because it's one of them. So I think we're good so far. So let's go for the last step, which is step 4. Okay, and I'll write step 4 over here near my formula for step 4 over to the right. Okay, so that's not, I didn't mean that as a closed dot. So step 4 would be the slope from one side. I'm going to change colors. The slope from one side. So what's the slope of 2 from the negative side? And the slope of 2 from the negative side would be the less than side. So that's c. And what is the slope of 2 at 2 from the positive side? And that would be, I would substitute 2 in here. So that's 2 times 2 minus c. So these two have to be equal. So c equals, I wonder if there's anything lower there. No. C equals 4 minus c. Work over here. So that would be 2c equals 4, c equals 2. So I have a c value. And then if I have a c value, I can substitute that right here. And then I'll get d. Okay, so that's 2 times 2 plus d equals 4 minus 2 times 2. So 0 equals, I think I can't write off the page. Okay, so 4 plus d equals 0. D equals negative 4. And they want to know what c plus d is. So that would be 2 plus negative 4, which is negative 2, which is b. We'll check Mr. Calculus just to make sure that I didn't make a careless mistake. Negative 2. Cool. So that's it. B. Okay. Mr. Calculus has had his solutions up for a long time. They're not in video form, but he has a post on his page that says if anybody finds an error to make sure that they let him know. So I know that he's already double checked those. Okay, let's do another one. Polar. Polar is not on this year's test. Do we care about knowing it? I care about knowing it. So if you want to just forward through this part of the video, that'd be okay. But I think I just want to do it anyway. Okay, so let's see. Which of the following expressions give the total area enclosed by the polar curve? Okay, remember the formula for polar is this for area. This is area in polar. It comes from the arc length formula, theta over 2 pi times pi r squared. Not the arc length, the area of a sector formula. And that's where 1/2 r squared theta comes from. And then we just change the theta into a d theta. Okay, so probably, I don't know if you'll need this for college or not. It'll just depend. So total area by the polar curve. Okay, I'm going to say let's use symmetry. Okay, let's use symmetry. So let's just do this part. Okay, so remember, you go radially outward. Oh, well, I guess we don't get to pick. Okay, they have what, 0 to pi for all of them? Okay, so they're going to, well, I don't know. We'll have to see where pi turns out to be, but we'll just check. What if you substitute in a 0? Sine of 0 is 0. Sine of 90 is 1. And sine of 180 is 0 again. Okay. So this is 90. And this is 180. Okay. Okay. So this would be from 0 to pi. 0 to pi. The formula is 1/2 r squared d theta. And our r, okay, our r is sine squared theta. And then we have 0 to 2 pi. And then I want to multiply by 2. Okay, I want to multiply by 2. Okay, so that would cancel, and we get sine to the 4th theta, d theta, 0 to pi, and 1. I'm a little uncomfortable, because if I was going to graph it, it does get the bottom half at the same time, because r is plus or minus 1. So I'm a little disturbed by that. So I'm going to go with D, but it does make me a little bit nervous. Yeah, Mr. Calculus has D. I just know that if I graphed this, if I pick 90 degrees, I do get r equals plus or minus 1. So it's very strange. But I guess that would be if I solve for r. Okay, so the next one. Let's see, that's the end of that page. Ooh, slope fields. Okay, slope fields is good. Slope fields could definitely be on the free response, probably where you have to draw your own. Which of the following could be a slope field for this differential equation? Okay, so some things we haven't talked about too much about slope fields in our class. What I like to do is I kind of like to make a chart, an XYM chart. I do believe I showed you that. What's interesting about this one is I like to find out where the slope is 0, where the slope is undefined. I like to just plot random values, kind of feels like random values. But I noticed that there's only y's here. So there being only y's here means that x could be anything. And it really just matters for y. So to me, I see if I substitute in a 1, I get 0. And if I substitute in a -1, I also get 0. So I kind of feel like just substituting values in. If I substitute in 2 for y, then this formula here, and this is still any, x can be anything, I get 3. Okay, so that's kind of steep, right? 3 over 1. Okay, and then if I substitute in -2, I also get 3. Okay. Can I ever get negatives slope? Yes. What if I plug in a half? So if I substitute in a half, that's a 4th minus 1, which is -3/4. And same thing for -1/2. Okay, so now let me look at the graph and see if this helps me at all. Okay, so let's see what my numbers are. Okay, so 2 is here, so 1 is about here. Y equals 1 is about here. I feel like there could be a horizontal line here. These are sloped up, those are sloped down. And I feel like there could be a horizontal line here. These are sloped down, these are sloped up. I think so. I kind of like this graph. Okay, I'm looking at A right now. Let me see if I can cross out some things from B. Okay, B. See this path right here of -1? Or any of these paths? If you look across the whole y equals something path, they should have the same slopes. Because any x value with y equal to 1, wherever 1 would be, like right here, 1 or any number, the slopes have to be the same. Not just they have to be 0, but they have to be the same. So I'm thinking this one can't be it. Because if I look at this row where all the y values are the same, okay, where the x's are the only thing that's different, they do not have the same slope. So this is definitely not it. C and D, same thing. Look here. See these? At y equals whatever this number is, it's not exactly -1, so I can't say that I want the slope to be 0, but the slopes should all be the same. So it's not that one. Same thing here. The slopes should all be the same. So let me look back up at A. So look at this whole row right here. See, for that y value, y equals, say, -1.8, all the slopes are the same because x doesn't change anything. Same thing here. Look at all those slopes. Those slopes are all the same. So this one I like because it only has one letter. So those two I don't like. Oh, and this one? Oh, this one looks good. So look at this one for the moment. Look at all those slopes. They all go in the same direction for every single y value. Okay. So I do feel good about the reason why I was crossing out B, C, and D. But let's go back up to our specific numbers. Okay, so we said at 1 and -1. So at y equals 1, which is about halfway in. Let me zoom in. The slope is 0. I don't think so. I don't think so, because this slope is positive, this slope is positive. I don't think there is a 0 in the middle of those two positives. It's possible, but I don't think so. I feel like the slope here would be 0. Here's a positive, here's a negative. Somewhere in the middle there, the slope had to be 0. Because you can't jump from positive to negative without a 0. So there has to be a 0 in there somewhere. So where are the only zeros for this one? The only slopes of zeros are 1 and -1. So I would say this is not -1. I don't see it. Okay, and then let's check. Let's check another one. At 2, the slope is 3. So at y equals 2 up here, so y equals 2, the slope is 3. I believe that. This one's okay. Down here, the slope at -2 is supposed to also be positive 3 over 1. This is from my table. So I would say this is no, because these slopes are negative. So this one's wrong. E is wrong. Okay, so I have enough evidence that the other ones are wrong. Okay, so I feel like the answer would be A. Okay, let's go to another one. XY plane, particle moves around along the parabola with constant speed. Let me write this equation down here. Constant speed. Now, speed is the absolute value of velocity. So 2 radical 10 actually means the velocity could be plus or minus 2 radical 10. I don't know which. dx dt is greater than 0. Okay, what's v? V isn't dx dt. Well, it depends. No, this is an xy plane. So v is not. And actually, that's probably not good what I just did. I'm going to erase this because v must be a vector here. So v is a vector. Okay, so dx dt, dy dt. Okay, so the way velocity works is velocity is dx dt, and this would be a position. The position vector, the velocity vector. The position vector is xy. There's no z because we're in 2D in BC Calc, not like IB. dx dt, dy dt. And then acceleration, if you need it, dx squared over dt squared. And then d squared y over dt squared. Okay, so the speed, which in AB and BC is the absolute value of velocity. It's the absolute value, it's the magnitude, which is like Pythagorean theorem here, it's a plus, and dx dt squared. And they said this was equal to 2 rad 10. Okay. And it says dx dt is positive. Okay, I don't really have that yet. What is the value of dy dt? Well, let's square both sides. Okay, so that's 4 times 10 equals dx dt squared plus dy dt squared. Okay, so I'm going to label 1, 2. So let's see. So 2, I'm going to use this. So this is now, I usually would just take the derivative and write y prime equals 2x minus 1, but I'm thinking that's not best. I think instead I'm going to use like related rates or implicit. So dy is 2x dx minus 1 dx. Kind of like implicit. But then I'm going to related rates it. Okay, which is put dy dt, dx dt, dx dt. Now I want to solve for dy dt with the particle at 2, 2. So I should be able to substitute in 2, 2 right here. So 2 dx dt minus 1 dx dt. So that'd be 4 dx dt's minus 1 dx dt. So that's 3 dx dt's. And that's dy dt. I guess I can put this over here. So 1/3 dy dt equals dx dt. And then I can substitute in. So this is 40 equals dx dt squared. So that's 1/3 dy dt squared plus dy dt squared. So that's 1/9 dy dt squared plus 1 dy dt squared equals 40. We could either deal with the fraction, which is not that big of a deal, or we could just multiply everything by 9, multiply by 9, multiply by 9, multiply by 9. Okay, so that's 360 equals dy dt squared. I just wish I had another letter for that. Squared plus 9. So that's one of them, and then that's 9 of them. I'm going to call it box. So I have 1 box plus 9 boxes, which is 10 boxes. And this is what's in my box. 360. I'm feeling happy because when I divide, I'm getting a perfect square. I do get plus or minus. Now it said dx dt was positive, but it didn't say anything about dy dt. It did say dx dt was positive. So let me substitute these back in here. 1/3 times plus or minus 6 equals dx dt. So we are going to have to choose the positive for dy dt if I want my dx dt to be positive. Okay, so dx dt is 1/3 times positive 6. So dy dt is going to be positive 6. I have to choose the positive one. And let's see if that's an answer. Let's see. Okay, I got D. Okay, let's see. Mr. Calculus. Okay, Mr. Calculus. I was looking at his his other one. What number are we on? 28. Oh, that's the last non-calculator one. D. Okay, you got what I got. Cool. Okay, now the tests were used to be a little different, right? The new ones are different, but our mock is the same length test as this. So it has the 28 questions and then the 17. So definitely the mock, the multiple choice, it helps you understand, do you know what you're doing for the free responses? So regardless that 2020 are free responses, it still is helpful. Okay, it still is helpful to check, to do these multiple choices to see what you're doing. Okay, and then let me see which ones we just did. Oh, we started at the logistic. Okay, so we did 24 through 28. It's a good spot to stop though on the non-calculator, on the calculator or non-calculator questions.